Okay, in my world, I just finished talking to you about 11.5a, but some of you did not finish the same day. But yesterday, which would be 11.5a, we were introduced to the normal distribution. We learned that there is a typical expectation of percentages between standard deviations, and we practiced answering basic questions based off of those values. We also discussed the need to find locations of values that were not specifically in a particular deviation. The z-value gives us the actual locations of particular values that may not have been listed in the normal distribution graph. What we're going to do today is look at, or in this lesson, is look at how technology can help us to answer specific questions about probability with normal distributions. So just get right to it, because again, hopefully you know this stuff, or at least have an idea to where you can follow what I'm doing. Number of videos uploaded daily to a video sharing sites normally distributed with mu, which is the mean equal whatever that number is, sigma equaling, or the standard deviation equaling that video, or that number of videos. Find the probability that the number of videos uploaded on a particular day is between 180,000 and 200,000. Now I want you to go with me here mentally. That means that they took stats on this stuff. They recorded it. They found the mean, because remember, we know how to find the mean, which is where you add everything up and divide. So let's say that they did this for a year. They analyzed their numbers for a year, and then they used statistics to find the standard deviation, which you can find anywhere as long as you have all the data. Remember, your standard deviation is telling you how spread or how consistent your values are. So this is information you can use, which is why statistics is important, especially in business, because you want to know this kind of stuff in terms of what to expect. It helps you make decisions. But anyway, they want the probability that today is going to be a day that will have this many videos. So the first thing you want to do is convert these numbers into z-values, because in terms of working with normal distribution, the numbers themselves are useless unless they are broken down to that chart. So we need to do 180,000. Again, I hope you know how to do the z-value, because I'm not going to write it down, but you'll do 180,000 minus your mean equals divided by your standard deviations, if you remember that. So that's negative 0.03. And then 200,000 minus 181,099 divided by your standard deviations 35644 gives me 0.53. Alright, so again, that is where your z-value practice actually comes in. You have to actually know how to do that if you're going to get that right, because if you don't know how to convert it, it's not going to work to your advantage. Now we need to find the area under the curve. So what we're looking at here is that negative 0.3 would be somewhere around here. So of course it's not going to be that, it's not going to be accurate because I'm not a computer. 0.53 is going to be around the halfway range, which means we are looking for that number. When we're looking for the probability, you're actually looking for the area under that curve. Calculus eventually will help you with that, but your technology can do it for you too, because of course we are not good enough to know what that percentage is based off of just looking at a curve. So it is difficult because our z-values are not specifically located on a deviation point, and this is where you must learn to use your textbooks and experiment a bit. A lot of the stuff that teachers do, me included, is not because we're super genius. It's because the instructions are in there and we have to actually do it, and you should not be afraid to just kind of read around and see, especially if you have the technology with you, as most of your teachers are going to give you textbooks. There are sometimes whenever you see like a picture of a graphing calculator or a calculator in general, just kind of read and see what's going on. And this book, in the book, is where I got it from. And this is actually from this problem that I got out of the book, but it says you can use a graphing calculator to display the area that corresponds to any z-value by selecting, and so let's go ahead and follow these directions. It says do second, which I'll do that. Distribution, I don't know what that means, but let's see. I don't see a DISTR button, but I do see DISTR here. So again, it might take time, but you go ahead and hit that button. Under the draw menu, let's see, I don't see draw. Oh, there's a draw menu and it's to the right of it, so arrow over. Select shade norm, which is what we want to do, and then pay attention to the fact that this has a number, a comma, and then another number. And so it means I probably have to use a comma. My lower number was right here, so negative 0.03, and 0.53, so I think there has to be a comma on this thing, and if you look at it, look at your calculator, there is a comma here, so the comma 0.53 and then graph, and notice that this does not look like this part here. The numbers are the same, but I want you to understand that you can still get there because this tells you more information. Remember that you have a window that you can zoom into, and this is saying -4 to 4, so turn from -4 to 4 with a scale of 1, which is right, and then y is going from 0 to 0.5 with a scale of 0.125. Let's see if that looks the same now. Okay, that's not what we're looking for. So let's go ahead and hit second, enter, and try it again. There we go. So I guess it's really not a graph, but it does kind of match what I showed you, where you're slightly off to the left because that's your point negative or -0.3, and then you're about a halfway over, and there is your area. So remember that your area is your probability, so it's about a 21% chance that whatever was going on was going to happen that way. Alright, using the same situation, what's the probability that the number of videos is greater than 250,000? So again, what you want to do is, I'm not going to write it because we have the information here. So greater than 250,000 means we now want to do our z number, because remember we cannot do anything without the z, so 250,000, which is right, minus your standard deviation, or so your mean 181099, which is that, divided by your standard deviation 35644, means that's about 1.93 standard deviations away. And so now that we know that, we want to now put that in our calculator. So how do you do greater than 250,000? Well, here's where your understanding of the curve comes into play. Whatever number we pick here, we want here, and we want from here all the way over. And the point is, if you think about it, all these numbers represent 99.7%. So what we're going to use, as you can see in this, or in the calculator picture that we have here, is that the typical numbers that you can use is just -4 to 4, because if majority of all your information is between -3 and 3, and that 0.15 is there, you can kind of approximate. I'm sorry you can't see it. If all that stuff is in between -3 and 3, and that last little part of its standard deviation has the last 0.5, and that's 99.7%, that's pretty much everybody. So what you could use on this is 4. So what we're going to do is go from, again, let's see if we can do it, second, distribute, draw, shade normal, and we want to go from, because you want it greater than 1.93, so my lower value is 1.93, and my high value is, I'm just going to put a 4, because again, the 4 should be about where everything stops. I don't need a number like 100, but I'm pretty sure I could use 100, but 4 should be right, and then you'll notice. Okay, let's clear that. I don't want to clear it all, but I guess we get the idea. It just doesn't take the other stuff away, which is crazy. But it does give me the area from 1.93 up to 4 is about 3%. And it makes sense because based off of this, it says that the average is 181,000, and the chance of you having 250,000 videos is pretty rare, just like the chance of having 1.93 deviations the other way, which would be like 100 and something thousand videos. But other than that, like I said, one more problem before we close out for this part here. Lifespans of a certain tire tread are normally distributed with mu of, or mean of 3166 miles and standard deviation of 1644. Find each probability by using the graphing calculator. So again, what we want to do here, just to kind of walk through it real quick, is find out this number. So remember that the first thing we want to do is, I'm going to go ahead and do second mem 712 because I need that thing cleared out. I can't keep looking at all those graphs. But the first thing we want to do is turn these into z-scores or z-values, because the numbers themselves are for anything. We need it broken down to the actual general graph. So 30,000 minus 31,066 equals, divided by your standard deviation, which is 1644, which is negative 0.65, and then do 32,000 minus 31,066 divided by my standard deviation, which is 0.57. And so now what we want to do again is graph that, and that's all it is. Again, that's all it is just taking that. Now you do your second distribute, go over to draw, shade norm, and then use these two numbers, so negative 0.65 comma 0.57. I don't think you need to close the part there, and maybe you don't see the graph, but it does still give us the area, which is 46%. Alright, and it makes sense because you're looking at the portion of the graph that is in the middle, which means that it should be high. It's a small area, but it is in the biggest part of the graph. Now if it was a small area over here, it'd be very small. Small area over here would be very small, but you're talking about that part being where it is over there. Alright, clear. Same thing, if you want x to be greater than 35,000, first thing you got to do is, and this probably is not going to happen because you're way away from the mean, and the standard deviation doesn't take me straight to 35,000. So looking at those numbers, it seems like it should be a small percentage, but again, 35,000 minus 31,066 divided by 1644 converts into a general number, and that, again, 2 standard deviations away means it's way far away. So that's actually 2.39. And so again, what we want to do is second distribute, again just following what the calculator or the book told us to do, and we want to go from 2.39. If you remember, if you're going greater than 35, that means you want to go as far as you can, so we can just use 4, because again 4 standard deviations is pretty far away from there, and it covers most of what you need. And again, as it does it, there we go, it converts it 0.008, which is about 1% chance. But again, our common sense and understanding of generally how the curve works and how those numbers work told us that it should have been small. So again, there are no questions for this lesson. I just wanted you to see the actual programming is not tough. The more you get into higher level math, the more it becomes a quest for learning a random process and then learning how to implement it and then leaving it behind forever until you get a job where you get paid hundreds of thousands of dollars to help someone who doesn't know math figure out a problem that they don't understand, that you may not completely understand, but you at least understand more. So other than that, enjoy your day. And again, for those of you who are here, we have one more lesson tomorrow, and that is it. So enjoy your day. Good luck.